Good morning everyone. Today we are going to learn the topic polynomials, which is in 10th class. So in these polynomials, what are the subtopics we have? Let us see one by one. First one is introduction of polynomials. Second one is relationship between zeros and coefficients of a polynomial. And third one is division algorithm for polynomials. So now we have to discuss one by one. Before going to learn the definition of a polynomial, let us know some basic concepts which are related to this polynomial. So that are nothing but first one is what is a variable, what is a constant, what is a term, and what is an algebraic expression. After these four we can go for a definition of polynomial. So first let us know what is a variable. Variable is nothing but a symbol which can take various numerical values. A symbol which can take various numerical values is called a variable. So see, I want to take a symbol x. So x is the symbol. So in place of x we can give 1, 2, 3, 4 like that. We can give any real number for this x. That means x is the symbol which takes various numerical values like -1, 0, 2 like that. We can give any real number for this x, so that it is called a variable. A symbol which can take various numerical values is called a variable. Next, what is a constant? What is a constant? A symbol which has a fixed value. A symbol which has a fixed value is called a constant. For suppose, take 100. 100 means nothing but 100 only. 100 we can't change at any other number, so that it is a fixed value. Hence it is called a constant. Like 5, 7, 150, -5. These are all the constants. A symbol which has a fixed value is called a constant. Next, what is a term? What is a term? Variable alone or constant alone are there by combination either multiplication or division. Constants alone or variables alone are there by combination either multiplication or division is called a term. Means for suppose I want to consider 4 is a constant. Only 4 is also called a term. X is a variable. Only x is also called a term. Or this combination by multiplication, that means 4 into x is nothing but 4 by x. 4 divided by x is nothing but 4 by x, or 4x is divided by 4 is nothing but x by 4. These are all called the terms. Only constants are called terms. Only variables are called terms. 4x, it is the product of 4 and x, it is also called term. 4 divided by x is called a term. X by 4 is also a term. So finally the definition of term is variables alone or constants alone or they by combination either multiplication or division is called a term. Next, an algebraic expression. Algebraic expression. So what is an algebraic expression? The combination of terms obtained by basic fundamental operators of arithmetic. What are the basic fundamental operators of arithmetic? I think plus, minus, into, division. These are all the basic fundamental operators of arithmetic. So the combination of terms obtained by basic fundamental operators of arithmetic is called an algebraic expression. Means for suppose 4x plus 3y, 4x plus 3y, 5x minus 3y, 4 divided by x square by 2x cube y. These are all the terms. Because these are the combination of terms obtained by basic fundamental operators of arithmetic. Plus or minus divided by 3 into y is nothing but 3y. This is also one of the algebraic expression. So the combination of terms obtained by basic fundamental operators of arithmetic is called an algebraic expression. Here we have to remember. So in this 4x plus 3y, how many terms are there? So 4x plus 3y contains 2 terms. 5x minus 3y contains 2 terms. This addition and that means minus, plus and minus only separates the terms. This multiplication, that is into and division, can't separate the terms. Here 4 by x square is only one term. X square by 2x cube y is only one term. 4x plus 3y, here we have two terms, that are 4x is one term, 3y is one term. 5x is one term, 3y is another term. So for suppose we can say 3xyz. Here how many terms are there? So we can say simply it is a product. So we have only one term. So finally you have to remember one thing, that is plus and minus only separates the terms. This is the definition of an algebraic expression. So after these four we can learn the definition of a polynomial. Now what is the definition of a polynomial? So we know already algebraic expression definition. So an algebraic expression involving in which the powers of variables are non-negative integers. An algebraic expression involving in which the powers of variables are non-negative integers is called a polynomial. What are the non-negative integers? Non-negative integers are nothing but whole numbers. What are the whole numbers? 0, 1, 2, 3. These are all the whole numbers. Non-negative integers is nothing but whole numbers. An algebraic expression involving in which the powers of variables are non-negative integers is called a polynomial. For example, if we see 3x square plus 4x minus 5 is a polynomial, because the powers of, first it is an algebraic expression involving in which the powers of variables are non-negative integers. So 2. Here the power is 2, here the power is 2. Here there is no power, that means I want to write that as x power 0. X power 0 is nothing but 1. 1 into 5, 5. So 2, 1, 0 are nothing but whole numbers. 2, 1, 0 are nothing but whole numbers. So it is a polynomial. For suppose I want to consider 4x plus 5 by root x. Is it a polynomial? No, because 4x plus 5 by root x can be written as 4x plus 5 into root x is nothing but x power 1 by 2. This x power 1 by 2 goes to numerator, then it becomes 4x plus 5 into x power minus 1 by 2. Here, this minus 1 by 2 is not a whole number, so that it is not a polynomial. Is it a polynomial? 3x power 3 by 4 minus 3x plus 4. It is a polynomial? No, because here the power is 1, okay. Here the power is 0. 0 and 1 are whole numbers, okay. But 3 by 4 is not a whole number. So remember that each and every variable contains a whole number, then only it is called a polynomial. So here 3 by 4 is not a whole number, it is a rational number, hence it is not a polynomial. And one more thing you have to remember, in this polynomial, all the variables must be present in the numerator. Then only we can decide it is a polynomial or not. See here root x, that means variable present in the denominator. So we can't say it is a polynomial or not. When this goes to numerator, that means root x can be written as x power minus 2. So here minus 1 by 2 is not a whole number. Hence it is not a polynomial. Again I am telling the definition of a polynomial, that is an algebraic expression involving in which the powers of variables are non-negative integers is called a polynomial. That is the definition of a polynomial. Next, let us know what is degree of polynomial. Degree of polynomial. The highest power of the variable in a term involving in the polynomial. The highest power of the variable of a term involving in the polynomial is called degree of the polynomial. See, 4x plus 5x square plus 9x cube plus 2. So like this I have taken one polynomial. So what is the highest power of the variable here? The highest power of the variable is 3. So that this 3 is called degree of this polynomial. This 3 is called degree of the polynomial. For suppose I consider 3x plus 5 into x power 3 by 4 minus 2x cube. Then what is the degree of the polynomial? See, it is first not a polynomial, because here the power is 3 by 4. It is not a polynomial, so that degree can't define. It is not a polynomial. For only polynomials, the degree E is nothing but highest power of the variable of a term involved in the polynomial. That means 3x cube plus 4x square minus 5x plus 10x power 4, like this. I have taken on polynomial. So the degree is 4. For suppose if they have given 2 or more variables, 3x square y plus 4x y plus 6x square plus 2x, like that. They have given any one polynomial. It is the polynomial in 2 variables. It is the polynomial in 1 variable. It is the polynomial in 1 variable. So here we have in 2 variables. For this, what is the degree? How to calculate the degree for each and every monomial? That means this is one of the monomial. Here the degree is how to add the sum of exponents of the variables. That means 2 plus 1. 2 plus 1 is nothing but 3. Here 2. Here 2. Here 1. So here highest value is 3. So that the degree of this polynomial involving 2 variables is 3. But in our 10th class mathematics polynomials, we have studied only about 1 variable. So that the degree of the polynomial is nothing but the highest power of the variable involving in the polynomial is nothing but degree of the polynomial. So now degree of polynomial is completed. So next, based on this degree, we have some types of polynomials. Let us discuss one by one. So based on degree, for suppose if the degree of the polynomial is 1, then it is called a linear polynomial. If the degree of the polynomial is 1, then it is called a linear polynomial. If the degree of the polynomial is 2, then it is called quadratic polynomial. If the degree of the polynomial is 3, then it is called cubic polynomial. If the degree of the polynomial is 4, then it is called biquadratic polynomial. If the degree of the polynomial is 1, then it is called linear polynomial. So what is the general form of a linear polynomial? That means, for suppose, first I want to take an example. So 2x plus 3. 2x plus 3. Here, what is the degree of this polynomial? 1. Degree of the polynomial is 1. So that it is called a linear polynomial. I want to take another polynomial. 10 minus 5x. 10 minus 5x. What is the degree of this polynomial? 1. So that it is called linear polynomial. Now we have to give the general form for this linear polynomial. Is ax plus b, comma, a not equal to 0. A comma b belongs to real numbers, nothing but constant. So a and b are the constants. X is the variable. The degree of the polynomial is 1. So that it is called a linear polynomial. It is the general form. Next, if the degree of the polynomial is 2, then it is called a quadratic polynomial. So I want to consider one polynomial like this: 2x square plus 3x plus 5. 2x square plus 3x plus 5. So it is a polynomial having degree 2. So that it is called a quadratic polynomial. X square minus 4x plus 5. X square minus 4x plus 5. Here the degree is 2, so that it is called a quadratic polynomial. So the general form of that quadratic polynomial is ax square plus bx plus c, where a not equal to 0 and a, b, c belongs to real numbers. Like that, the degree of the polynomial is 3, then it is called a cubic polynomial. So the general form is ax cube plus bx square plus cx plus d, where a not equal to 0. A, B, C, D belongs to real numbers. Like the degree of the polynomial is 4, then it is called biquadratic polynomial. Nothing but the general form is ax power 4 plus bx cube plus cx square plus dx plus c, comma, a not equal to 0. A, B, C, D belongs to R. So here the degree of the polynomial is 4, biquadratic polynomial 3, cubic 2, quadratic 1, linear polynomial, like that we have. So if suppose the degree of the polynomial is 5, then what is the name of that polynomial? So that has no name. So if the degree of the polynomial is 5, then it is called 5th degree polynomial. 5th degree polynomial. You can say that is simply 5th degree polynomial. If the degree is 6, then it is called 6th degree polynomial. Degree is 7, that is called 7th degree polynomial. Like that. If the degree of the polynomial is n, then it is called nth degree polynomial. If the degree of the polynomial is n, then it is called nth degree polynomial. So what is the general form of a nth degree polynomial? So I want to write this as here nth degree polynomial is, I want to consider that polynomial as p of x. It is p of x or f of x, g of x, anyone. So it is nothing but the polynomial in the variable x. So a naught x power n plus a1 x power n minus 1 plus a2 x power n minus 2 plus and so on plus an, where this a naught is not equal to 0 and a naught, a1, a2 and so on belongs to real numbers and n belongs to non-negative integers, nothing but whole numbers. N belongs to whole numbers. See here, linear polynomial, the power is 1, here the power is 2. So if you observe the powers or exponents are in descending order, 3, 2, 1, 0, 4, 3, 2, 1, 0, like that. Here also n minus 1, n minus 2 and so on 0. This is the nth degree polynomial general form. Here a naught not equal to 0 and a naught, a1, a2 and so on an are called real numbers and this n is nothing but a whole number. So here how to remember this a naught, the highest power of the variable coefficient, has one particular name, that is called leading coefficient. That is called leading coefficient. Leading coefficient. Here also x power 4. This is a quadratic polynomial. The leading coefficient is a. Here the leading coefficient also a. Here also a. Here also a. So the highest power of the variable coefficient is nothing but leading coefficient of that polynomial. So this is about the degree of polynomial based types of polynomials based on degree. Okay. Next, value of polynomial. Value of a polynomial. Value of a polynomial. Let us consider any one polynomial p of x is equal to 4x square minus 3x plus 1. Like that I have taken one polynomial. So what is the value of polynomial? Is nothing but, so we have to substitute any one value in place of x. Already I taught about x. X is nothing but a variable symbol which contains various numerical values. In place of x we can give any real number. For suppose I want to give in place of x as 1. So x is equal to 1. P of 1 is equal to 4 into 1 square minus 3 into 1 plus 1. It's nothing but 4. 1 square is nothing but 1. 1 into 4, 4. 3 into 1, 3 minus 3 plus 1. 4 plus 1, 5. 5 minus 3, 2. So the value of the polynomial p of x is equal to 4x square minus 3x plus 1 at x equal to 1 is 2. This is value of the polynomial. Like that we can give x equal to 0. So then p of 0 is equal to 4 into 0 square minus 3 into 0 plus 1. Remember 0 minus 0 plus 1, that is equal to 1. So this is the value of the polynomial. For suppose if I consider k is any real number. K is any real number like 1, 0 like that. K is any one real number. If suppose we can get p of k is equal to 0. Suppose we can get p of k is equal to 0. Then k is called 0 of this polynomial. So k is any real number and if we get p of k is equal to 0, then k is called 0 polynomial. That I will tell you. 0 polynomial. So 0 of the polynomial. 0 of the polynomial. For suppose I consider a polynomial p of x is equal to x square minus 5x plus 6. Like that I have taken one polynomial. Suppose put x is equal to 2. P of 2 is equal to 2 square minus 5 into 2 plus 6. That is equal to 2 square nothing but 4 minus 10 plus 6. 4 plus 6, 10. 10 minus 10, 0. So here this is a polynomial. In place of x we substitute 2, then we get p of 2 is equal to 0. Hence 2 2 is called 0 of this polynomial. That means k is any real number. K is any real number. If we get p of k is equal to 0, then we say that k is the 0 of the polynomial p of x. Like that. It is the 0 of the polynomial. Another one, if we substitute x equal to 3, p of 3 is equal to 3 square minus 5 into 3 plus 6. 3 square means 9. Minus 5 into 3 minus 15 plus 6. 9 plus 6, 15. 15 minus 15, 0. So hence 3 is called 0 of this polynomial. For suppose I substitute in place of x as 1. P of 1 is equal to 1 square minus 5 into 1 plus 6. 1 square nothing but 1 minus 5 into 1, 5 plus 6. 1 plus 6, 7. 7 minus 5, 2. So here we get P of 1 is equal to 2. So that 2 is called not a 0 of this polynomial. Here we can get P of 3 equal to 0. Hence 3 is called 0 of this polynomial. 2 is called 0 of this polynomial. That is about 0 of the polynomial. So next, what is 0 polynomial? What is 0 polynomial and what is a constant polynomial? We have to discuss about these two polynomials definitions. Then after we can go for geometrical representation of a polynomial. So 0 polynomial. 0 polynomial is different from 0 of the polynomial. 0 of the polynomial is nothing but in place of x we can substitute any value. Then if we get the value of the polynomial is equal to 0, then that value is called 0 of the polynomial. 0 polynomial means if a polynomial contains all the coefficients are zeros. If a polynomial contains all the coefficients are zeros, then it's called a 0 polynomial. For suppose I want to consider ax square plus bx plus c. If a is equal to b is equal to c equal to 0, then it is called a 0 polynomial. If we observe a is equal to b is equal to 0, that means all the coefficients are zeros, so that it is called a 0 polynomial. That means 0 into x square, 0 into x plus 0. So it is called a 0 polynomial. Next, so what is a constant polynomial means? If a polynomial contains only a constant term, that is called a constant polynomial. For suppose 2010. So it is one of the polynomial contains only one term, so that it is called contains only a constant term, so that it is called a constant polynomial. That means 5 minus 3. So every constant term is nothing but a constant polynomial. Simply how to remember like that. 0 polynomial means if a polynomial contains the coefficients of all zeros, then it's called a 0 polynomial. Remember that 0 polynomial is different from 0 of the polynomial. How to remember that? Next, what is the degree of 0 polynomial and what is the degree of constant polynomial? So first I want to tell degree of constant polynomial. So I want to consider 2. 2 is a constant polynomial. 2 I want to write as 2 into 1. Nothing but 2 into 1 can be written as variable power 0. X power 0 is nothing but 1. Y power 0 nothing but 1. 3 power 0, that means some t power 0. All are 1s. So here it is can be written as 2 into x power 0. It is one of the polynomial. The highest power of the polynomial is 0. That is nothing but degree of the polynomial. Hence the degree of the constant polynomial is 0. Degree of constant polynomial is 0. So like that. What is the degree of 0 polynomial? Degree of 0 polynomial is not defined. Degree of 0 polynomial is not defined. How can we say? For suppose I consider 2x square minus 3x plus 4. So everyone can say here the degree is, the highest power is 2, so that it is called degree of the polynomial is 2. I consider 3x cube minus 5x square plus 2. So here the degree of the polynomial is 3. Here what is the degree of the polynomial? So if you observe, all the coefficients are zeros. Nothing but we can't say the degree is 2, the degree is 1, the degree is 0 like that. For suppose if anyone say the degree is 2, the degree is 2. So 0 into 2 x square nothing but 0, it becomes 0. Then 0 into x plus 0. So now what is the degree? Here highest power is 1, so the degree is, here the degree is 1. So 0 into anything? 0. So here the highest power is, I want to write this as x power 0. The degree is 0. So here the degree is 2. Here the degree is, again I am telling this. If we consider the polynomial 0 into x square plus 0 into x plus 0. So 0 into x square. Highest power is 2, so that the degree is 2. Here 0 into x square is nothing but 0. Leave this term. Then we have remaining 0 into x plus 0. So 0 into x plus 0. Here the highest power is 1. So the degree is 1. 0 into x, nothing but 0. 0. So here 0 can be written as 0 into x power 0. Here the degree is 0. Here the degree is 2. Here the degree is 1. Here the degree is 0. So we can't say one particular value. That means one particular degree for this 0 polynomial. So that the degree of this 0 polynomial is not defined. But if we see here, everyone can say the highest power of the variable is 2. So that the degree is 2. The highest power of the variable is 3. So that the degree is 3. Here we can't say particularly one value so that the degree of the 0 polynomial is not defined. Remember, these 2 points are very important. Degree of 0 polynomial is not defined. Degree of constant polynomial is 0. So this is about value of polynomial, 0 of the polynomial, 0 polynomial and constant polynomial. So next, if they have given any one polynomial, how can we find the zeros of that polynomial? If they have given any one polynomial, suppose they have given linear polynomial p of x equal to 3x minus 2. Like that, they have given one polynomial. How can we find the zero of this polynomial? 0 is nothing but the value of x. 0 is nothing but the value of x. So how can we find zero of this polynomial? Let us see. So for finding this zero of this polynomial, let me how to write. To find zeros, let us assume that p of x is equal to 0. To find zeros, let us assume that p of x equal to 0. 3x minus 2, p of x is nothing but 3x minus 2 equal to 0. This implies 3x is equal to 2. X is equal to 2 by 3. So this 2 by 3 is nothing but 0 of this polynomial. This 2 by 3 is nothing but 0 of this polynomial. And one more thing. X minus 2 by 3. If 2 by 3 is the 0 of this polynomial, then x minus 2 by 3 is a factor of this polynomial. Factor of this polynomial p of x. So, if for suppose p of a is equal to 0, that means a is called 0 of the polynomial p of x. So, p of a equal to 0, then we say that x minus a is a factor of p of x. X minus a is factor of p of x and vice versa. If x minus a is a factor of p of x, then p of a equal to 0. For suppose p of minus a equal to 0, this implies and implied by x plus a is a factor of p of x. X minus a is x plus a is a factor of p of x, like that. So this is about 0 of the linear polynomial. So now let us take 0 of a quadratic polynomial. By using that quadratic polynomial, we can find zeros of cubic polynomial by quadratic polynomial by using division algorithm. So that we have to see in next video. So let us consider the polynomial x square minus 4x minus 3. X square minus 3x minus 4. Let us consider this polynomial. So how can we find the zeros of this polynomial? So to find zeros of this polynomial, let us write the p of x is equal to 0. So now x square minus 3x minus 4 equal to 0. So now for finding zeros of this quadratic polynomial, first you have to multiply x square coefficient and the constant term. X square coefficient and the constant term. X square coefficient is 1 here and constant term is not 4. Here the constant term is minus 4. 1 into minus 4 is nothing but minus 4. Now you have to split minus 4 into two factors. The sum of the two factors must be the coefficient of x, nothing but minus 3. So how to split minus 4 into two factors? The sum of the two factors must be middle term coefficient. X coefficient is minus 3. So I want to write that as minus 4 into 1. Minus 4 into 1 is nothing but minus 4 into 1 is nothing but minus 4. sum of the terms. So minus 4 plus 1 is equal to minus 3. So quotient of middle term. So this I want to write as x square. So minus 4x plus x, minus 4x plus x, minus 4x plus x is nothing but minus 3x, minus 4 is equal to 0. So in these two terms, what is the common value? First we have to common in these two terms. What is the common value? X. So common value. X common means so we can get x minus 4, x into x minus 4, x into x square, x into minus 4, minus 4x. Now we have to write this x minus 4 as it is here. It is a simple trick. X minus 4 as it is here. Now we have to keep the sign what we have here, plus or minus. So we have here plus, so I have to write plus. So by what term we can multiply x, we can get only x, 1 only. So 1 into x, 1x, 1 into minus 4, minus 4. So in these two terms, what is the value of, or what is the common value? X minus 4. Common value. Here, common value is x. Here, plus 1 is equal to 0. So now, a into b is equal to 0. A into b is equal to 0 is nothing but either a equal to 0 or b equal to 0 or both equal to 0. Then only it will become 0. A equal to 0 or b equal to 0. Like that I want to write here x minus 4 equal to 0 or x plus 1 is equal to 0. X is equal to 4 or x is equal to minus 1. The value of the variable are nothing but zeros of that polynomial. So here the zeros of this polynomial are 4 and minus 1. The zeros of the polynomial are 4 and minus 1. Like that if you consider cubic polynomial. I want to consider a cubic polynomial like this, x cube minus x square. X cube minus x square is one of the polynomials. So to find one of the cubic polynomial, to find zeros, so let p of x equal to 0. So x cube minus x square equal to 0. In these two terms, the common value is x square. Common that. Then what we get? X minus 1 equal to 0. So x square means I want to write x square as x into x minus 1 equal to 0. That means either x equal to 0 or x equal to 0 or x equal to 1. So the zeros of this x minus 1 equal to 0, nothing but x is equal to 1. The zeros of this cubic polynomial are 0, 0 and 1. Here we can get two equal zeros, that is nothing but 0. 0 and 1 are the zeros of this polynomial. Okay, this is about the zeros of the polynomial for linear, quadratic and cubic. So if they have given any polynomial, cubic polynomial in another way. Now, the geometrical representation of a polynomial. Geometrical representation of a polynomial. So in this 10th class polynomials, we can discuss only about linear polynomial, cubic polynomial and quadratic polynomials only. So first one I want to consider is straight line. Linear polynomial. So what is the graphical representation of a linear polynomial? Let us see. So let us consider any one linear polynomial. I want to consider linear polynomial as p of x is equal to 2x minus 3. 2x minus 3. So for drawing graph, geometrical representation nothing but we can draw a graph. For drawing graph, I want to assume this p of x as y because we need coordinates that are nothing but x and y. So I want to consider this p of x as y is equal to 2x minus 3. So here I want to find 2 points. For suppose put x is equal to 0, then y becomes 3. X equal to 0. 2 into 0 means 0. 0 minus 3 minus 3. So now I can put y is equal to 0. Then we get 2x minus 3 is equal to 0. 2x is equal to 3. X is equal to 3 by 2. 3 by 2 is nothing but 1.5. So 1.5. Here I got 2 points that are 0 comma minus 3 and 1.5 comma 0. So by using these 2 points we can draw a graph. Let us draw x-axis and y-axis. Origin. So 1, 2, 3, 4, 6, minus 1, minus 2, minus 3, minus 4, 1, 2, 3, like that. Draw a graph. So now plot these points. So already how we plot the points, already we studied in 9th class. So first we have to plot the point 0, minus 3, 0, minus 3. On x-axis 0 and y-axis minus 3, 0, minus 3. This is the point. Next 1.5 comma 0 on x-axis 1.5, y-axis 0, nothing but here. This is a point 0 comma minus 3. This is the point 1.5 comma 0. Now join the 2 points and extend that. So this is graph of y is equal to 2x minus 3. So what we get? So the graph of linear polynomial we got as a straight line. So the geometrical representation of a linear polynomial is a straight line. The geometrical representation of a linear polynomial is straight line. Next, go for quadratic polynomial. Quadratic polynomial. How can we draw the graph of quadratic polynomial? So let us consider the quadratic polynomial as y is equal to some x square minus 2x minus 3. X square minus 2x minus 3. This is the quadratic polynomial. So for finding for drawing the graph of quadratic polynomial, first we have to find the zeros of this polynomial. First find the zeros of this polynomial. How can we find zeros of this polynomial? Already I taught in previous. That means so to find zeros, like x square minus 2x minus 3 is equal to 0. Now find x square coefficient and constant term. The product of x square coefficient and constant term is minus 3. Now split minus 3 into 2 factors. The sum of the 2 factors is must be minus 2. I want to write that minus 3 into 1. Minus 3 into 1, nothing but minus 3. Minus 3 plus 1, minus 2. So this is nothing but x square minus 3x plus x minus 3 is equal to 0. So in these two terms the common value is x. Common that x into x minus 3. Write this x minus 3 as it is here. By what term we can multiply x? We can get x nothing but 1 equal to 0. So x minus 3 into x plus 1 is equal to 0. Nothing but x minus 3 equal to 0 or x plus 1 is equal to 0. X equal to 3 or x equal to minus 1. So first, when for drawing the graph of quadratic polynomial, first we have to calculate the zeros of that polynomial. Then after we can draw a table. Then we can draw a graph of that polynomial. So here the zeros are 3 and minus 1. So how can we draw the table? Very simple. See, x, y. So what are the zeros we can get? 3 and minus 1. Write in ascending order. Minus 1 and 3. So simply how to write all the integers in between minus 1 and 3. What are the integers between minus 1 and 3? So 0, 1, 2. And take one integer before minus 1 and after 3. Before minus 1 integer is minus 2. After 3 is 4. See, minus 2, minus 1, 0, 1, 2, 3, 4. So minus 1 and 3 are the zeros. The value of p of x, consider as p of x. The value of, otherwise y. The value of y at x equal to minus 1 is 0 because minus 1 is the zero of the polynomial. At 3 also 0. So now calculate it minus 2, 0, 1, 2 and 4. So at minus 2, so substitute x value as minus 2 in y is equal to x square minus 2x minus 3. So minus 2 means x plus minus 2 whole square, 2 into minus 2 minus 3. Minus 2 whole square is nothing but 4. Minus 2 minus plus 4 minus 3. 4 plus 4, 8. 8 minus 3 equal to 5. So here the value is 5. You can write simply the value of y at x equal to 4 is also 5. Let us see it is correct or not. Once we have to check. At x equal to 4. So 4 square minus 2 into 4 minus 3. 4 square means 16. 2 into 4, 8 minus 3. 16 minus 8 minus 3 minus 11. 16 minus 11, 5. So at x equal to 4 also the value of y is 5. So now at x equal to 0, in place of x we have to keep 0. 0 square, 0. Minus 2 into 0, 0. Minus 3. Nothing but minus 3. So no need to calculate at x equal to the value also minus 3. Once we have to verify again. At x equal to 1. 1 square, 2 into 1 minus 3. 1 square means 1. 2 into 1, 2 minus 3. 1 minus 5. 1 minus 5 is nothing but minus 4. So the points are minus 2 comma 5, minus 1 comma 0, 0 comma minus 3, 1 comma minus 4, 2 comma minus 3, 3 comma 0, 4 comma 5. 4 comma 5. These are the points. We have to plot these points on the graph paper. Then we can get one shape, that is minus 2 comma 5. First point is minus 2 on x-axis, minus 2, y-axis 5. So here I have taken the scale on x-axis. On x-axis 1 centimeter equal to 1 unit. On y-axis 1 centimeter equal to 1 unit. This is the scale I have taken for drawing this graph. So first point is minus 2 comma 5. Minus 2 on x-axis, minus 2, y-axis 5. So minus 2 comma 5. It is the point. Next one is minus 1 0. Minus 1 0. This is the point. 0 comma minus 3. On x-axis 0, y-axis minus 3. This is the point. Next 1 comma minus 4. On x-axis 1, y-axis 4. 1 minus 4. Next 3 comma 0. 3 comma 0. 4 comma 5. On x-axis 4, y-axis 5. So now plot the points. Join the points. So this is the graph of the polynomial y is equal to x square minus 2x minus 3. So what are the zeros of this polynomial through graph means where the graph of the polynomial intersects the x-axis, the points x coordinates are nothing but zeros of the polynomial. Here where the graph intersects the x-axis at minus 1 comma 0 and 3 comma 0, so that minus 1 and 3 are called the zeros of this polynomial. So where the graph intersects the x-axis, the points x coordinates are nothing but zeros of the polynomial. Minus 1 and 3 are the zeros of the polynomial. So again I am telling how can we draw the graph of this polynomial. Let us see. So first we have to calculate the zeros of the polynomial and write that values in a table. So here we get minus 1 and 3 are the zeros. Minus 1 and 3 are the zeros. Now we have to take the integers between minus 1 and 3 and one integer before minus 1 and after 3, like minus 2, minus 1, 0, 1, 2, 3, 4 are the values of x. Now we have to calculate the values of y. Substitute each and every value of x in this y. We can get values of y. So here we get the points. Now here the first point is plot the points on the graph paper. Plot the points on the graph paper and join them with a free hand. Then it represents one shape. That shape is nothing but parabola. parabola. So the graph of quadratic polynomial is parabola. The graph of quadratic polynomial is parabola. So now where the graph, that means this graph intersects the x-axis at minus 1 comma 0 and 3 comma 0. Hence minus 1 and 3 are called the zeros of the polynomial. Like this, we can draw the graph of cubic polynomial also. So if you observe here, the graph of linear polynomial is straight line. The graph of quadratic polynomial is parabola. Like that, we don't have any one particular name for a graph of cubic polynomial or a biquadratic polynomial. So if you see, this is graph of a cubic polynomial because it intersects the x-axis at 3 distinct points. So that is graph of a cubic polynomial. So it is also graph of cubic polynomial because it is not a linear polynomial, it is not a quadratic polynomial. Hence we have like this shape, so that it is graph of cubic polynomial. For suppose we take like this, means this is graph of a biquadratic polynomial, like that. In this polynomials we study only linear polynomial graph and quadratic polynomial graph, and through graph of cubic polynomial we can only find the zeros of the cubic polynomial. Okay. Now discuss some important points related to quadratic polynomial. So we know the general form of a quadratic polynomial is p of x equal to ax square plus bx plus c. It is the general form of a quadratic polynomial where a not equal to 0, a comma b and c belongs to real numbers. So already we know the graph of quadratic polynomial is parabola. A not equal to 0 is nothing but either a greater than 0 or a less than 0. A greater than 0 or a less than 0. So the graph of quadratic polynomial is parabola. First, suppose in a quadratic polynomial, if a greater than 0, then we can get the parabola as upwards, open upwards parabola. Open upwards parabola. A is less than 0, then we can get the parabola is open downwards parabola. Open downwards parabola. So these are the two important points. So first of all, x square minus 4x plus 5. What is the graph of this polynomial? Is parabola only, but here x square coefficient, in particular x square coefficient is 1. 1 is nothing but greater than 0. So the graph of that polynomial is open upwards parabola. For suppose we consider x square plus 4x minus 5 minus x square plus 4x minus 5. What is the graph of this polynomial? Nothing but parabola. In particular, x square coefficient is equal to minus 1. Minus 1 is nothing but less than 0. So at that time, open downwards parabola. Okay. Next, one more important point. The number of zeros of a linear polynomial. Linear polynomial has how many number of zeros otherwise? So linear polynomial has only one zero. Linear polynomial has only one zero. Quadratic polynomial has how many number of zeros? So quadratic polynomial has at most 2 zeros. Quadratic polynomial has at most 2 zeros. What is the meaning of at most? At most is nothing but maximum 2 zeros. See. For suppose I have taken a greater than 0, x-axis and y-axis. So the graph of quadratic polynomial may be like this. So here the graph of the quadratic polynomial p of x intersects x-axis at a and a dash. That means at two distinct points. That means it has 2 zeros. So the quadratic polynomial has 2 zeros. For suppose graph may be like this. So it touches the x-axis at only one point. Touches the x-axis at only one point means it has 2 equal zeros. 2 equal zeros we consider as only 1 0. 2 equal zeros we consider as only 1 0. If a graph intersects the x-axis at two distinct points, then it has 2 zeros. Only one point, it touches only at one point, then it has only 2 equal zeros. 2 equal zeros is nothing but 1 0. And for suppose if the graph is like this, if the graph is like this, graph is like this means it is the graph does not intersect x-axis that does not intersect x-axis at any point, so that it has no zeros. If the graph does not intersect x-axis at any point, so that we can call it as it has no zeros. No zeros. If a graph intersects at two distinct points, two zeros, or only one point, one zero, no points, no zeros. That means it has at most two zeros. Means the quadratic polynomial has either two zeros or one zero or no zeros. Like that. For a cubic polynomial has how many number of zeros? At most three zeros. Biquadratic polynomial has at most four zeros. Nth degree polynomial has how many number of zeros? Nth degree polynomial has at most n zeros. At most n zeros. This at most word is very important. So this is about the number of zeros of a polynomial. Linear polynomial has only one zero. Quadratic polynomial has at most two zeros. Cubic polynomial has at most 3 zeros. Nth degree polynomial has at most n zeros. A greater than 0 means the shape of the graph is like this. A less than 0 means open downwards like that. This one has touches only at one point. And last one does not intersect x-axis at any point. So that is about a less than 0. So this is about the interaction of polynomials. We can discuss relationship between zeros and coefficients of polynomial in next video. Thank you one and all.